Yep. How we doing? I made it. Have I got? Yeah, I've got audio. I've got audio. It's all working. Is it all working? No, I haven't checked yet. I think we're all working. Webcam? Yeah. How we doing, everyone? bitlastminute.com again, as usual, but you know how it is. So again, loads of people have been chopped off the top, but I think it was Chris, all the gear, no idea, first in today. And we got Theo, George, Ninja, Benji, Colin, Sean, Man Cave Workshops in. Who else we got in? I'm here. Dom, Driver Film Shortwave, Rob Titheridge, Michael Hyde, fully BFO'd up, Michael, hopefully. Nick's in. Are you back from the MOT yet, Nick? Derek, hi Derek. Electrifying. Hopefully not electrifying me. But you never know. Put on his makeup. I was actually. I'm just cleaning up the bench because it's a hell of a mess. There's loads of bits of wire and all sorts of stuff knocking about. Yeah, shaky start because of the internet connection, George. So don't you worry about it. Victor, how you doing, mate? And Doug. Rob Cross, hi Rob. Paddy, hi Paddy. Dropping frames, I'm doing 26 frames a second apparently. And I'm only broadcasting at 25, so looks good my end. MOT passed, well done Nick. Oh, that's a relief, isn't it? Always is. BFO's nearly done, Michael. Hopefully you understood all the information I put in there, Michael. Because yeah, the screen print on the board is not the same as the schematic, so yeah, that's what confused me. It took me a bit longer to build it than should have done, but got there in the end. Oh, I've got so much rubbish on the bench here at the moment, unreal. But it is cleaned up, sort of. So buy Benji stuff. Buy me a car. The old one's rusted. Well, Chris managed to get his car. My lad got his car through the MOT. Done all the work himself. So well done to Chris. Sorted. It's grand, Paddy. Yeah. You could, Dom, a GoFundMe. You could do. I need a new car, so GoFundMe. So I've been messing about with this power supply. Now, why the hell am I messing with this power supply? Well, it's all down to Tim, who was asking about the power supplies for the Roberts radios. I think it was the PS12, the 12-volt one, which is what started it all going, really. Got my head thinking that I've got a load of bits here that I could probably make into a power supply. And we ended up with a Frankenstein's power supply actually worked on a breadboard, which is here. I better get that out, I suppose, because that's our bit of history. So it's all in pieces here at the moment. It's all falling apart as usual. But let's get the camera down and you can see. I'm sure you remember last week anyway, but I'll show it to you anyway. So this is the sort of thing I cobbled up. I've actually converted it back to what have I done? I've connected it back to 24 volts at the moment, but as I say, the problem with this was this transformer's really big. It's not really practical to go in a small case, you know, a small power supply case. So I thought I need to shrink that down a bit. Plus, the voltages weren't ideal on this. Now, Rob came up with an idea of, Rob Tiveridge came up with an idea of switching the coils on this, the output windings, because there's two sets of windings, a 012 and a 012, so it's a 24 volt or two 12 volts. So switching that so as maybe we could use the 24 volts for 18 volts and the two 12 volts for maybe 9 to 12 volts or 6 to 12 volts. So that was one plan, but I didn't follow that through really, because I thought, well, I'll have a look around, and I came up with another. I'm grabbing this, and it's actually plugged into the mains. So that worked. And if you watched last Wednesday's stream, you'll see this up and running. And I haven't touched it. I've left it as it is, just as sort of a reference as to where we've come from, really. Bit cobbled together, but it did actually work in the end, which I was pretty chuffed with, to be fair. And that spurred me on to go a bit further with it. So after getting a lot of help and talking to a few people, I came up with, well, I decided to go my own way at first, as I do, because I've got to try and teach myself, haven't I? I can't keep feeding off of everybody else all the time. So I thought, well, look at the Hacker power supply. I reckon that had a 15 volt transformer in it. I've got to be careful because this is actually connected up to the mains at the moment. So ignore this for a minute. Pretend you haven't seen that. This is the transformer. So I mean, this is a 15 volt transformer, same as what I think is in the Hacker power supply, but I'm not 100% sure yet, but we'll get it out. So I mean, if you compare it to that one, you can't really see it like that. I don't really want to stick it at the main side. So if you compare them like for like, I mean, that's huge compared to this. It's really heavy. This is a lot. I mean, I've got this all taped off so as I can't touch it. I've cable tied the mains cable on, and I've got some insulation underneath so I can't touch any of the mains connections. So I came up with this, and I've stuck it on this strip board. I think it's strip board, isn't it? I mean, you can see on the back, it's just strips of copper with holes in them. So that's where we got to. And Chris, Mr. All the Gear Idea, suggested that maybe I get a DC load. So I got a bit scared then, because I know DC loads are pretty expensive. So I thought, oh, I don't want to do that. You know, the bank account won't run to that at the moment. So anyway, he did mention about the low cost ones. So I had a shop around, and I came up with this thing from Amazon, and there was some sort of 5% offer on, and I think I got it for 27 quid in the end. Oh, and I've knocked that up to an amplet. Christ. See, that's been running at an amp. It's not that hot either. Do you see that? That was an amp. So really, I think it had dropped the voltage down, didn't it, at an amp? Yeah, you can see the voltage is dropping off. So this is a DC load. But you know, I mean, this is capable of an amp and a half, this regulator, without any extra transistors or anything else on it. It's capable of an amp and a half. And that's not even, it's not hot. I mean, that's been, I don't know how long I've run that at an amp for, but it's it's got all sorts of thermal protection in the regulator itself. It's an LM317. We'll go into some of the technical stuff. Yeah, I thought that was a bit warm. Well, obviously it works. So yeah, I mean, I've got this set at 100, 110, 120 milliamps at the moment, which is far more than a radio's ever going to need. And this is really what it's for powering up either the Hacker or Roberts or any other radio come to that wants a battery supply. Because we can cobble up some adapters to just run this, and I mean it's not very big. It's, you know, that'll easily fit into a case. I mean, it's, if you look at the Hacker VP408, if we move all this over a bit. So this is the Hacker power supply, and I mean it's, apart from my massive great heat sink, this would fit in there. So the idea is to try and build something like this. Now this is adjustable between 6 and 18 volts. So 6 and 18 volts, wow. And you've got the current, the maximum continuous current. Let's get in a bit closer on that, because this is what's baffling me, because a lot of people have said that what I'm trying to do won't work because of the limitations of the transformer, etc. So this is the spec on the VP408, and apologies if I'm not looking at the screen. I'll catch up with the new arrivals shortly. So we've got potentiometer here that will go from 6 to 18, and maximum continuous current 150 milliamps at 6 volts, but at 18 volts it says you can draw 400 milliamps maximum continuous output. So it's obviously performing better at the top end. So I'm not really sure why this can do it, and my contraption allegedly can't. I mean, I think it can, but it's not as good as the Hacker one, I don't think, but it should be not far off. So if you have a look at my little circuit, this is my transformer, so it's I'll point with something plastic just in case, but I've got it all capped and taped off. This is the mains input here. This is the primary. It's a board mounted transformer, which I wanted so as it would go on a PCB. If I just angle it a little bit in there, you can see I've got one of these package bridge rectifiers straight into my filter cap, which is 1000 microfarads at 50 volts. Then that goes pretty much straight to the input of the regulator, which is on this massive great heatsink. Again, a bit overkill, but you know, I thought rather more than less. I'd rather overkill it than underkill it. So the secondary on this is only one, it's only got one output, so it's 15 volts secondary. So it's not a multiple tap, it's just 15 volts secondary. So up the top here, you can see this is an output capacitor. There's an output, there's a resistor in there across the adjust and the output, I believe. I might be adjusting the input actually. I've got a 5K pot to adjust the voltage, and I've also popped a 500 milliamp fuse in there as well, just for safe measures. And I've already popped that once, so just as well I put one in, really, wouldn't it? So that's the construction of it. It's pretty basic. It's pretty basic, but what we need to check, and I've been sort of scratching my head a little bit because I plugged this into a radio yesterday. I got a hell of a lot of interference off of it. So we'll try and demonstrate that in a minute. But at the moment, as you can see, if I get my DC load back in shot, you can see it's Where are we? Down a bit, down a bit. There we go. So it's sat quite happily at 18 volts. I mean, this needs tweaking a little bit because that's not exactly right according to my multimeter. So there is an adjustment pot on here. So I'm assuming that is an adjustment for possibly the... So if I stick my multimeter across the terminals, (17.98), and that's reading 18.2. So I don't know if this pot here no, that's ampage by the looks of it. Doesn't look like there's a trim pot for the voltage, so unless it's actually on the board itself, it might be actually on the board. Yeah, there is a little trimmer on there. But there's two trimmers. I adjust, V adjust. So maybe we can tweak that in a bit. There is two trimmers in there, but I'm not going to worry about that for a minute. It's good enough. So let's just catch up with who's come in, because I've missed a few people here. Where have we got? Barry. Hi, Barry. You've got a few power supply projects, Benji. Hi, Dennis. Don't forget to crunch the thumbs up. How you doing, Dennis? That board's handy for little circuits like this. Turn it down. It did get pretty warm. I mean, to be fair, on 18 volts, it's like lukewarm. It's literally as lukewarm. It's not even. It's lukewarm. Hi, Gary. How are you? Brian, how you doing, mate? The VA rating of the transformer, 16 volt amps, Ninja. Pretty big transistor. Hi, Andy Tobin, how are you? Does it produce linear power? It's got a linear transformer, Sean. It's not switch mode. It's a linear. If it worked right, it wouldn't interfere. Yeah, this is the thing. Hi, Daniel, how are you? No worries. Hi, Peter, 13HN516. Okay. So, one of the issues is well, let's not look at issues first. Let's look at what it's doing. So I'm just going to turn it around so as I can get at the terminals underneath. Because one of the things that determines how this works is the voltages. So I'm going to first of all go across, stick it on AC. I'm going to go across the transformer. Obviously this is on and running with a load, but so with the load on, I'm getting 18.76 off of the secondary of the transformer. If I go across the bridge rectifier now, which is there and there, let's put it on to DC. There. So we get 23.3 volts rectified. I mean, if I turn the load right off, so off load I'm getting 25.2 volts. So really, you know, if I'm looking for 18 volts out, 25.2 is enough headroom, isn't it? Because you know, in the info that I've read, and I've done a lot of blimmin' reading trying to get my head around this. In the info that I've read, it says you should allow 4 volts headroom, really. So from the voltage you want out of it, you should have 4 volts available. So if I wind it back up to, let's just leave it at around 100 milliamps, which is going to be more than enough for most radios. If it'll stay at 100, what's it now, 100? Yeah. So it drops down to 23.2. So then it was suggested to test between the input. Okay, I've got nothing there. Why have I got nothing? So the input's 23.2 and the output's 18. So I've still got 5 volts headroom at 10 milliamps. Well, sorry, 100 milliamps, 110 milliamps. So most of these radios run about 50 milliamps flat out, 50, 60 milliamps. So, Fat Tony, how you doing, Tony? Let's make sure I haven't missed anybody. So, yeah. Yeah, that was a thing I was thinking of doing, because I have got some bigger smoothing caps. Where are they? I've got a 50 volt Rubicon 2200, but that's all very well, Ninja. But what would bumping up the smoothing cap do? Would that stop it falling off? Because let me get my camera over to the scope. Let's get a camera over to the scope if it'll do it without unplugging itself and crashing everything again as usual. So where can we put the scope? Let's just zoom in on the scope a little bit. Let's put the scope in number 3. Okay, so here's the scope. So I've been sort of playing about. I had a quick play with this before I went to bed last night, but that's literally all I've done. So if I scope the signal, what have we got there? So it's fairly, that's just me moving it about, I think. Well, there is some weird noise there, isn't there? What I need to do really is, if I turn that off a minute and just pull the thing off, I need to just pop a couple bits of wire in the outlet here so I can see what's happening. John, how are you? John Bonham. Yeah, that's coming later, Sean. We need to get our heads around what's happening with it at the moment, really, before we investigate that. John is saying you have a bit less than 4 volts delta. Linear reg has 1.25 approximately internal reference voltage. Okay, so you're saying that it's pushing it at 18 volts. I think it's the current more than the voltage that's I don't know, but it's obviously related, isn't it? You know, the transformers are warm, but not mental. What I was trying to do is just get a couple wires in the output so as I can connect to it, because it's going to be easier for measuring if I've got something I can hook onto. So just cut a bit of this off. Yeah, I think it's, I don't know, I only tried it once, so you know, it wasn't an exhaustive test, Ninja. It was just a quick, I've got it hooked up, I did all the tests on it, it looked perfect, and then I connected it up to radio and I was getting a lot of noise, and Nick thought it was probably switching noise from the, well, not switching, but noise from the bridge rectifier, because there's no capacitors across the diodes on it. So bear with me, I'm just trying to chuck some wires in here at the moment so as I can test this a bit easier. So I think me moving was yeah, me moving was causing it to fluctuate. RV, how you doing? I broke it. I could have broke it. Well, it might be I broke it. I did manage to pop the fuse on it when I was having a play. So I've got one longer than the other, so it shouldn't short out. I'll tell you what, this is the wrong wire for this probably. Yeah. Let's use the wire I was going to use to start with before I change my mind. Always the same, innit? The other wire was thinner, so it wasn't catching in the connector. Noise may be high stray flux from the transformer lamination, Dennis, really? I haven't blown it up yet, Harvey. Don't say things like that. Tempting fate. I nearly did, because I knocked it when I moved it earlier and it was running at over an amp for quite some time. It didn't blow it up. I'm sure it cut down on its internal limiting though, just as well. It is got protection from the cruncher. Okay, so I'll stick a little bit of solder on that, stick a wire in it just so I can hook the test leads up to it, that's all. That's why I'm messing. As I say, this is not finished by any means. This is an ongoing project, and the plan is in the grand scheme of things is to actually get a circuit board manufactured to save us messing about buying these expensive Hacker and Roberts power supplies that aren't that great. You know, I was hoping to try and build something that was actually better than that, but I don't know that I've achieved that, to be fair. But as I say, it's ongoing, and I'm grateful to everybody that's given me help on it so far. Okay, right. That's nice. Let's get me end for me scope. Let's just power it up again. Just as a question then, for those that know, I mean, I was running that at an amp. I was running that at an amp with an 18 volt load, 18 volts with a 1 amp, over at 1 amp load on it. How come it didn't pop my 500 milliamp fuse then? That's a bit of a strange one. So let's connect this up properly then. Oh, actually, I was going to just solder the ends, wasn't I? Stop them fraying. Yeah, I'd have thought that was the whole purpose of the fuse, was to stop it, was to blow it if it was drawing too much current. It's a fast blow as well, 500 milliamp. Try 100 NF cap from the input of the regulator to the ground. Yeah, there's a few little tricks that I found to try and tame it. I've got to pull the plug every time I switch the. I've got this on the isolation transformer at the moment. I've got to pull the plug every time because it gives a hell of a whack. So you can see the scope now. I mean, that's a fairly, that's offload. What's it measuring? Oh, it's AC coupled at the moment. I'm pretty sure it's AC coupled. Auto set. Okay, I'm going to turn that one off. Let's pull that one down. Measure. Source. I'm pretty sure I'm AC coupled. Yeah, I'm AC coupled. 10 times probe. 200 meg band limit off. Anyway. Let's go to measure again. So peak to peak, that's saying around about sort of 90 to 100 millivolts, peak to peak. So let's connect the load back up. It's not really done anything. So if I wind the load up, it's gone a bit bonkers, look. I don't. So when I get to yeah, so it's dropping out. I don't know if this scope's triggered properly. Okay. Okay. That's better, right. So 280 milliamps, 290, 300. So there, it's doing that. Basically at 400 milliamps, and I suspect the voltage has dropped off. I didn't look at this to see if the voltage drops. Yeah, so the voltage is starting to drop off there, look. So I think we need to just go in. For some reason it's not zoomed into my scope. Maybe we need to stick that in the main shot and then stick the no. Go over that side. So do that again. What light is shining on that one? It's that one there. Let's just pop that light off to stop the glare. That's better. So let's do that again. Let's just wind this one up. So really, I mean, 100 milliamps is probably more than we need. I mean, 200 milliamps. There, it's dropping out. About 350, is it? You can see there's a bit of noise appearing on it there, and then we got that horrible thing at 400. So that's 18 volts. So what I haven't done is I haven't messed about with it and tried this at other voltages. So let's drop it down to 12 volts. So I'm just going to go in and can I get you in on that? No, wrong one. I've got so many buttons to play with here. It's a job to know what to do here. Right, so I'm just going to go in on this pot. I'm just going to wind that back. So as we get 12 volts. Because it might be that this is only doing this on... okay. So we're now at 12 volts. I mean, this is not even warm, the heat sink now at the moment. It's not even lukewarm, stone cold. So let's wind the ampage up on this and see what happens. So it's sat at nearly an amp there and nothing's happening. Look, there's no noise on that. So 12 volts, it doesn't appear to be happening. Unusual, strange. Ganesh, how you doing? I'm going to check back through the chat in a second. Just bear with me. Let me get my drink there now. I've got the drink off of the table today, because we've got mains on there. Right, sorry about that. So let me spill the drink to see some fuse pop-ins. Right, okay, let me go back through the chat because I've missed quite a lot out. Okay, I'm back to where I was. Let me just go into picture-in-picture there a minute. What's wrong with it? Is what you say. It seems perfect, doesn't it? But when I had it connected up to radio, it's really noisy. But we'll try that again in a minute. I think we're pushing it at 18 volts, and I think Nick was quite adamant that it wouldn't work at 18. There'll be no smoke. So Tony's saying try 100 NF cap from the input of the regulator to ground. Yeah, that's definitely on the cards, Tony. John is saying because the fuse protects based on current and time. That's the fast blow and slow blow. It's a fast blow fuse, John, but I thought it would have popped at an amp. Afternoon, Chris. All the gear, no idea. Welcome. Also, is the profuse in the primary or secondary side? It's got a fuse built into the transformer on the primary, and that fuse that I've got on the circuit that you can see is in the secondary, John. Your Amazon order just arrived. I think my RS parcel's just arrived. I might need a PCB soon. I think the idea is for me to try and do one myself, Sean, but aided by those that know. Afternoon, Avengi Zillis. Yeah, thanks, Chris. Yeah, there's no caps across the bridge. It's a package bridge, and the other thing that Simon mentioned was let's make sure we don't short that to there, otherwise we will have a pop. Simon mentioned that I ought to be using a 50-volt bridge in this. Where are we? You can just about see the bridge in the picture-in-picture there. So this is actually, I think it's either a 600 or an 800 volt bridge I've got in here. So he says I ought to be using a 50-volt bridge, which is a good call. So I'm thinking of possibly going over, and I'll get the schematic up in a minute. Use the proper scope underneath. Oh, I see what you're saying, yeah. Yeah, you're right, Tony. The trouble is I can't get to that one very easy. Well, I can now because I've just cleared it off, actually. A team on Dragon's Den? I don't think so, Sean. Oh, dear. Yeah, the problem is can you buy a linear power supply for these radios off the shelf, Chris? I don't think you can, really. The data sheet for the regulator is 32 pages, Ninja. I know, it's mental, isn't it? I've got some summary data sheets for it. Still catching up with the chat. Easy EDA, I think that's the one that's been suggested. Dom. They sell the 317T regulator boards on eBay for less than $10. Just add the transformer and go. Yeah, I mean, if they come with a heatsink, Doug, that's a bargain, really. You find you can lay out a board and etch it in a similar amount of time to build an Avero board. I have got some, I've got some ferric chloride here, Chris, and I've got some blank PCBs as well. So only single-sided, but that's all we're going to need. Most of the radios will draw about 100 milliamps at high volume. That's what I was thinking, John. I don't really need anything excessive. You ought to do a video on one of your power supply builds, Benji. I'd be happy to watch that. I'm always up for a bit of help. It takes several times the rated current to blow a fuse. It blew it pretty quick when I put the power across, well, put the load across it the wrong way yesterday, Chris. It blew it pretty sharpish. Hi Rich, how are you here? You haven't got enough headroom to get 18 volt out. Change transformer from 15 volt to 18 volt. Yeah, I think the problem, Rich, is if you go that way and go for a higher transformer, am I right in saying that the wattage for the lower values like goes through the roof? But I do want to pull. See, that's getting warm now. It's getting warm. It's getting warm, but not burny warm. I'm just fondling the heatsink, and it's getting warm, but not mental. So yeah, I think you're right. You sent a photo. You did, Doug. Yes, thank you very much. Has anyone got any 0.15 inch Vero board? Okay. Nice one, Avengi. Just use a capacitor dropper PSU. We're going with this, George, no matter what you want to say. This is where we're going. This is where we are with it. I'm doing it because I want to. Right, let's just zoom out a bit. I think the neighbours are breaking the lockdown rules at the moment, which is winding Mrs. Cruncher up no end. Can hear her out there. She'll be out there after him. Ah, dear. So John is saying primary voltage times current equals secondary voltage plus current. So if SC is lower voltage than primary draws less current than secondary. So if we have a look at the voltages on this then. See if we can do this without shorting anything out. So I mean, we should be fine here, but it is obviously getting warmer now because I've got a lower voltage. So our input obviously 23, our output is 12. No problem at all with that, and it doesn't seem to be doing anything on the scope at all. No problem at all. Tony, It's flat as a pancake, the scope. Yeah, neighbours. I don't know, Mrs. Cruncher's not happy. End of the day, we're supposed to be in lockdown. You're not supposed to be visiting your families, etc. You're supposed to be staying in, and they don't seem to understand that next door. So the mother-in-law's around there, indoors with them, which is obviously not allowed. So yeah, obviously no problem at 12, apart from we got the increase in wattage. But I mean, I have got a pretty hefty heatsink on it, so that is dissipating the heat, no problem at all. Thanks, Tony. Thank you, mate. Yes. So I mean, we can wind it down further. Which camera am I at? I don't know. I've got so many cameras going here at the moment. So get that one out of the way. So I mean, I did find somewhere a calculation saying about 9 volts. Where are we? There was a calculation saying what the wattage was. It was input plus output divided by the current, I think, was the wattage. Is that right? So I think we had 20, say we got 23 plus 9 equals, is it divided? Was it times, I think, 0.2. Yeah, so at 9 volts, that's kicking 6.4 watts. Well, that's at 200 milliamps. That's actually 120. Let's just that again then. I think that's right. So 23 plus 9 equals times 0.12. So that's 3.84 watts at 9 volts. Well, this should easily dissipate that. And I mean, so this transformer is obviously good. I mean, it's getting warm, but not like hot so that I can't keep my hand on it. And I suppose if I go down to 6 volts plus 23 times 0.12, yes, if I drop down to 6 volts, that gets me about 8.7. That's based on 1.2, well, 0.12 amps, 120 milliamps. But again, there's no noise on it really. So should I be checking something else? So let's take it down further. Flogging a dead horse. No, it's fine. It's no problem. So the only thing is, it's at the top top end up near 18 volts, it is struggling, isn't it? That's the thing. So I could hook this up as just a 3-way transformer for maybe the Roberts set. So I could stick it as a 6 volt, a 9 volt, and a 12 volt, because I've got a 24 volt, another 24 volts transformer. I've got the 24 volt with 2 tap ends, but it sounds from what we're saying that I need to be 18 volt really. The transformer needs to be 22 volts. So the actual headroom is determined from the rectified voltage, not the actual transformer secondary. It's from the rectified voltage. So I think the 24 volt one was doing about 36 volts on the rectified voltage. This one's doing about 25. But yeah, that's getting warmer, but it's still okay. Transformer needs switched output for high and low voltages. So there's a 24 volt transformer. It's just that little bit bulkier again. I mean, this is a 24 volt amp, I think. 25 volt amp at 24 volts. So that is a bit smaller. It would still fit on that Vero board. No, actually it would overhang the Vero board. That I mustn't get too close because I could induce a voltage into it, I think. So what we need to do is stick this on a radio and see what happens in it, because this is where the fun begins. So that's still, I think that's still usable at 6 volts, you know. Because I mean, it's I think the maximum rating on this regulator with a heatsink is about 15 watts, and if I'm only hitting it with 6 watts, no, 8 at 6 volts, so I'm well within the spec, provided the heatsink's working on. I mean, I can keep my hand on that. Look, it is getting warm, but unfortunately I haven't got a thermocouple to measure the temperature. And this one does do temperature, this meter, but I haven't got a thermocouple probe for it, unfortunately. Or I would measure it and we could see the difference, because that's important as well. Because no point putting this in a plastic case if it gets so hot it melts it. John is saying the regulator dissipating the delta volts, voltage in, voltage out, times the current, plus the output voltage, times current, roughly about 2 watts at 9 volts. Out. 2 watts. Why did I get 8.76? Oh, at 9 volts, sorry. I'm at 6 volts at the moment, John. Yeah, I mean, you can smell that it's getting warm. Right, so what else do we need to do? Connect it to a radio next. So let's take that load off a minute to turn it off. Let's get the scope off. you can keep your hand on it, it's under 50. All right, okay. So it will do 6 volts then. So really, this will do 6, 9, and 12. And what I did, can you see that? Possibly. Let's get rid of that other camera for a minute. No, we want that one, that one. So you can just about see that. I mean, what I did is I measured the value across the from the input to the potentiometer to the wiper, and these are the values of resistors that I need for the different voltages. And so the idea is to remove the potentiometer and have a switch to switch in these resistors. So solder these resistors onto the board and then let the switch do the voltages. I think if we go up to, if we went up to say a 24 volt transformer and tried to squeeze 6 volt out of that, I think it would be struggling. It would get really hot, wouldn't it? I think if you exceed its specs, Doug, I hear what you're saying. If you exceed its specs, it's got a thermal overload capability, so it just shuts down, doesn't it? So you can't really damage it as such. The other thing that I learnt about the 317T is that it doesn't like anything lower than 10 milliamps. So if you're going to be running anything sort of 10 milliamps or lower, you need to put a load resistor across it as well, because it doesn't like it apparently. So I've learned a lot about this by messing with it, to be fair. Right, let's have a swig of water because my mouth's getting dry because I've been rabbiting on too much. Hi Nigel Hill, I definitely can damage him. At 6 volts, 12 milliamps, it's around 2.76 watts. Yeah, my calculation is totally wrong there then, John. I should work fine at that. And I mean, probably, to be fair, it will run at 18 volts, provided I keep the ampage down on it. The other thing that Chris suggested, and hopefully Mr. RS has brought that now, is to go with a self-resetting fuse, which I didn't understand at first, but I looked it up, and yeah, very good idea. Much smaller footprint, and it'll allow me to get my resistors in to switch between the different voltages. So really, probably summarizing, this one is probably only good for 12, 9 and 6 volts, and I need to go up to probably an 18 volt transformer for 18 volts, which I suppose in the grand scheme of things sounds about right, doesn't it? So let's stick a radio on this, because I've got some different radios now that I haven't tried. So this needs switching, and it also needs, as Chris said, LEDs. So we want LEDs really, so we can see what's happening. So how are we going to do this? Let me find a radio first. Let's put that to one side. Let's move that out of the way. Let's keep my wires because I'll probably need those. So let me have a look. Let's go 18 volts first then, and we'll just, that'll enable us to rule out 18 volts totally, won't it? So I've got a Sovereign 2 here that we repaired quite some time ago. I can't remember exactly what we've done to it, but I have repaired it, because I've got very few working radios, because they're all customer radios that I fix, and I haven't got a lot of working ones myself. But this one, I think we've recapped this this, and no, we haven't fully recapped it. We've only done the amplifier board on this, but I have got a couple flying leads off of it. So can I get that up to there? It's not quite going to reach, is it? How are we going to do this? Have a think, Graham. Let's put me 2 bits of stubby lead in there and we'll just croc clip it across. This is disconnected from the mains at the moment, and please be aware, people, if anyone's thinking of playing with this sort of thing themselves, this is mains voltage stuff here. It's not I've got it protected as such so as I can work on it, but it really needs to go in an enclosure where it can't be touched. So it's only temporarily hooked up at the moment. So I'm just going to use a couple clip leads, and we're just going to hook this across. Actually, what we'll do to start with, we'll have a look and see what current this is drawing. I'll hook it up to the power supply first. So where are we? Where's the power supply? Let's go. So there's a power supply. What are we on? 18 volts, which is, this is an 18 volt radio. So let's stick it on FM.
Of injured, congrats. Would you agree? What bits of that analysis?
It being a non-fit very established. It's huge. It's a global, it's a global player. It bought scripts. It became even bigger, and it does sort of fill a void, but. You do have to wonder in terms of market saturation at this point, just because there are, you see some.
Jesus, that was bloody loud. So that full whack was topping 200 milliamps, just touching 200 milliamps, wasn't it? Okay. So in with our power supply. Let me just wind it up to 18 volts. Because I mean, if it's usable, obviously it's not drawing. Well, it's not a lot of. It's not creating a lot of power. It's not drawing a lot of wattage at 18 volts. Thanks, John. Right, so I'm just where am I? Let's put that in number 3, perhaps. Just have a look, see what this is doing. See, we're at 6 volts. Let's wind it up to 18. To be fair, I mean, this will run probably down at 16 volts, no problem at all. So I don't have to run it at 18. I could probably run it on 16 or less. Okay. So let's sort this out. Let's get rid of number 3. Let's get that out of the way for a minute. Get that out of the way. So we're connecting this up to that and there.
What we would say is a finite list of talented storytellers in that space, of which you've got one on this show, who are incredible, and they're battling. The war is really about how big your checkbook is, and how big can you go out and get these things.
Whereas your argument is that you're doing passion verticals.
We're in a different lane. We're in passions, and we're in the non-scripted space, and we want to aggregate that.
Which I think is the first time we've got the phrase passion verticals onto the media show, which I'd say is a sign of success. You mentioned Julianne, and just before Julianne, I come to Julianne, who's laughing at that.
Let's
Excuse me. I've got to ask you about, JB, about one of the biggest talking points in British media at the moment, which is the upcoming launch of GB News. There's plenty of chat about how it could amount to the biggest shake-up of British television news in 30 years. You've invested. You're one of the lead investors. What was their pitch to you as to why you should invest? Because it was obviously persuasive.
Yeah, look, we're generally not in the news business in most places, but we're also an opportunistic and a company that looks at opportunities and looks at sort of what we call white spaces, spaces where we think there's opportunities because there's a voice that's not present or a brand and a customer segment that's not being served. And this.
So now I don't know what's causing that noise. That's my phone, I think. This isn't causing any noise on FM by the sound of it. So when I will go to medium wave and long wave, so really that's coping quite well. You can see it's getting noisy. It's definitely getting noisy as we go up in volume.
Plurality of voices in media. So,
and do you believe in impartiality? Because the worry
so let me just take that back to say 16 volts.
As well. The question some people have is that we might be moving towards a more American style of TV news. I think some of the comparisons with Fox News may be overstated, but impartiality is a different thing to the kind of balance which LBC do on radio. Do you care about whether or not that impartiality is observed?
We do. We do, and we don't.
So we're at 16 volts now.
The commentary of the fear of this sort of moving to a kind of U.S. media style.
Do you think it's fair, or is it overstated?
Overstated, way overstated. At the end of the day, first of all, we have great respect for the UK and the UK regulatory. The regulations and the way it has to work in the UK are very different than the US, and so.
To be fair, that's not doing too bad, really. Aston, how you doing? You got one of what in bits? A Sovereign 2?
The sort of story of your career,
we'll
get into that in a moment. Suddenly you've got this huge number of people to pitch to, and they've got a lot of money.
I know, it's terrific. I mean, if I think about the number of buyers that there were when I first came out to the US,
Now this was the issue. If I go to long wave, that's actually not as bad as it was on the other radio, to be fair. Let's wind it back up to 18 volts then and try that again. It might have been at 18 volts because that's where I was trying it yesterday. made me jump. Ignore the scope because it's not connected at the moment. Let's reconnect the scope. Get off. Good short circuit protection. Well, okay. What have I done to it now? What happened there? Have I shorted it somehow? No, still got 18 volts outlet, output. Hmm. 18 volts into the radio. Could the power supply have killed the radio? Got 18 volts coming into the amp. I don't know. So let's just turn that off a minute. That's one thing. I haven't got a power switch on this either. Let's see what happens if you stick a VP8 real close. It might do, Sean. It might do. Yeah, I'm using 1000 microfarad for the filter. Let me just catch up with the chat. Use a radio that you consider expendable. Ninja. Yeah, they're all expendable. I'm not. This is just an old Sovereign 2, and I'm not sure what's going on with that. Could be something on the amplifier board, but that one's. I put new outputs on that board. So I'm not sure what's going on with that, but anyway, that's not the point. I think it's probably all these leads I got hooked up everywhere. So I did manage to short them together just now. It's the problem when you've got clip leads everywhere, isn't it? Anyway, we're going to move on from that. So that's really not too bad. I mean, the radio that I was getting a lot of interference on was an old Herald medium wave and long wave set. You can calculate the junction temperature fairly easily if you know the thermal resistance of the heat sink. Let's have a look then. Good at RS. So I think that noise isn't unacceptable. I mean, I had to hold it right up next to it to get it to make a noise. I mean, there was a faint noise in the background, but you wouldn't have heard that over the microphone. Let me find my orders, and I'll let you know what the spec was on that heatsink. So that's taken ages for some reason. Let's get my chat up and carry on going through it. So Benji said it needs plenty of isolation between the primary and secondary if it's soldered to 0.1 inch Veraboard. Yeah, it really, I mean, I've stripped all the insulation, all the tracks off around the primary, Benji, so there's loads of isolation around that. Still catching up with the chat. George's new video, very good, George. I did put a little comment in there, George, on the amplifier board. So let's quickly, I'm still catching up with the... I'll tell you what, RS is running slow today. I think the whole internet's going slow. This is a problem. When I'm connected up live streaming, the internet runs mega slow here. Right, let's find my last order, which I think was that one, was it? Or was it that one? It was that one, I think. So again, really, all these bits and experimenting on all the rest of it, I mean, I wouldn't be able to do if it wasn't for you guys helping me out, super chats, etc. So thank you very much for that. So let me see if I can get, what's the spec on this? The thermal resistance on that is 6 kilowatts, Chris, if that means anything to you. Let me just see if I can get the spec sheet up on it. 6 kilowatts it says. Let me just see if I can get that up, the proper spec sheet up on it. What are you doing now, you crazy thing? Let me just see what I've got open here. Let me get rid of that one and that one a minute. Okay. So that's the heatsink that I picked up. 6 kW. It's not 6 kilowatts, is it? It's 6 K per watt. That doesn't tell us a lot. That's just a line drawing of it. (6K/W), Chris, whatever that means. Heatsink 6 and 7.5, so it's the 6 version. It's a pretty lumpy heatsink, really. I probably went over the top. I probably went over the top for that, didn't I? So let me just catch up with the rest of the chat. Yeah, that's what I was saying, Chris. Oh, I've got this light off now, haven't I? I put that back on because that was reflecting on the thing. Yeah, so it'll happily run on 16 volts. It'll run down a lot lower than that because they do run on pretty flat batteries. That's coming from the wiring, not from the regulator. Sounds like AC mains. Yeah, yeah. Oh, 6 kelvins per watt. You should have a theta value. Yeah, it doesn't really say, Chris, does it? It's not it's measured in C per watt. Let's have a look. What is it? So it's a Fisher Electronic. See if I can find a data sheet, a proper one on it. Search Google. Data sheet. There's nothing. The data sheet's pretty rubbish on it, Chris, to be honest. It's just got that KW even on the manufacturer's website, Fisher Electronic. I mean, this is the 76 one, which is different. 7650 is a 6 kW. Yeah, it doesn't really say, Chris. I've just looked at the manufacturer's page and it's exactly the same that as well. It's got that KW. There's no theta or anything like that on it. Noisy diodes in the bridge. I think you're right, Nick. I think if I bridge those diodes with I think it's 10 NF caps. Magic smoke. Another project. 100 UF is a reservoir, not a filter. Might have smoked the speaker coil. Shouldn't have done, Ninja. Variable long tracks acting as aerials. Yeah, I have isolated a lot of it, Rob, but I haven't gone and done it all. Can you measure mains wall power, 240 volts AC with an oscilloscope? Will the instrument show you the volts? Does it have an internal mechanism to distinguish from DC to AC? You can generation, but I've never connected my scope up to mains before. I'd rather not mess with that. How noisy is the actual Roberts power supply? We're going to check that out in a minute with this. I'm going to pull this Hacker VP408 apart now. What John Bonham just said. Has the radio been done in? I don't know, Theo, really. I've just I shorted the two leads out, unfortunately, so it's probably popped one of the transistors on the amp. Is it worth scoping the speaker output to see if the interference is 50 or 100 hertz? I could do. Sean's saying that the VP408 case blocks a lot of noise. Yeah, I'm struggling to keep up with the chat here. George is saying 6 Kelvin per watt, so I think George is right there. German, so they use the full SI unit. It's 100 hertz. Yeah. 10 NF ceramic, short the leads as close as possible to the rectifier and output regulator. Short leads as close as possible to the rectifier and the output regulator. Doing all right, Rob. Doing all right. Managed to pop one of the radios. Which one should we blow up next? let's blow up Robert's R707 next then. Where am I? There we go. Let's blow up a Robert's R707 next. So this is 12 volts. I'm wondering whether, I mean, Chris mentioned about building a current limiting circuit for this, which I think is a good idea because, you know, if something's wrong, the radio could have a short and it could pull a hell of a load of current from that, couldn't it? So I think that's something that needs to be added on to that. Almost certainly. This is a problem because I shorted that across. It's potentially can whack a load. So just make sure this is working first. Yes, it's working at the moment. It might not be in a while, but it is at the moment. So this is a radio that I've bought in to restore. I haven't got round to it yet. $12 now. Just see what voltage we're on. I'm just going to pop that back to 12 from 18. Don't want 18 up it. Yes, we need some sort of current limiting circuit. And Chris found one using an LM317 actually, which looked quite good. Right, where's my leads gone? So again, we ought to see what this is drawing on the power supply first. Wow. Roughly. No. Simon, how you doing? UK FMCB radio service, and how you doing, Richard? And Richard saying that RS Components do the 5.15 inch Vera board. Demolition Derby. Darren, how you doing? Yes, we looked at that with the previous transformer, Darren, which was a 24 volt transformer. And Rob came up with quite a nice schematic to do that, but we hadn't done it as yet. But I wanted a smaller transformer ideally. Right, let's connect this up to the power supply a minute. Yeah, I wanted to try and get a smaller transformer down that we could stick in a smaller sort of case, similar to the, say, the VP408 is where I was aiming. So again, I'm going to be a bit more careful with the leads this time so as they don't touch. So that one on the power supply is peaking up around 300 milliamps. But again, this should cope with that no problem. So let's transfer it over to the power supply. This should be a bit easier because there's not some flying leads this time. that we can short out.
Israel directing the European Film Philharmonic Orchestra, and Brahms getting us off to a flying start with a 5 o'clock hour of class.
We're brought in. We're only a week before the end of the deadline. If you are making these fundamental changes to how you trade, if this was a business plan, you would be doing it over a year, 18 months, 2 years, something like that. So there was always...
Okay, let's try this on long wave then. So you can hear that low level rumble, can't you? So it's like a helicopter. So let's just disconnect that. I'm going to pop it back on the other power supply and see if we've still got that rumble. So we've still got the rumble. So let's turn this off. Still there. It's probably this scope, I expect. Could be that. Yeah, not sure. So I've got something else interfering. Yeah, got something else interfering. So let's hook that back up to the to my power supply then. So I think this one is good for all of it. I just need to sort out some current limiting. I think I shorted that to the case earlier. So that's exactly the same. Okay. So that runs that, no problem at all. I think I'm just being finicky again with that noise. I think that is just me holding it really close to the radio. I wanted a perfectly clean supply, you see, but I don't think that's physically possible. Yeah, it does sound strange, doesn't it? You think a PTC is a good idea for overloads? It's a PTC. Wallow. Richard. Yeah, good of you to join us, Richard. We're messing about trying to build a power supply. Well, I've built a power supply, to be fair. There's some modifier. I've got it sat here at 240 volts, propped on the bench at the moment, so I need to be a little bit careful. Let's get rid of that picture-in-picture. That one. So yeah, that's it, built. This is a 24 volt transformer, but it's only got a single secondary winding. It's not dual. The other one I've got is dual. But it's massive. It's too big really. It's too big to sit on your dining room table with your radio. It's all right on the bench, but then I've got a bench supply. If I want to put it on the bench, I've got a bench supply. So I've got one other radio, which is a 9-volt. This is a Roberts R900. It does work.
We need to play the cards that we've been dealt, i.e. the protocol, rather than just throwing it.
So that works. Let's just pop the battery out. So the reason I got this one out, it says 9 volts, so this is all 3 radios now, all 3 voltages, and the only other one is 6 volts, which is like the old Roberts RT1. I definitely need to sort some current limiting out, without a doubt. So what I've hooked up for this, so as I can use it, is I've made one of these up. So all I've done is I've reversed the polarity of these so as they'll clip on like that. And then I can clip them onto the power supply. So if we pop back onto the power supply a minute, can you see that? No, I better put that in the main shot. So if we go back to the power supply, let's just connect it up to the bench supply, see what current it's pulling. And this is 9 volts now. So we do need to really be looking at a power supply that's able to run a couple hundred milliamps, really, looking at some of these radios.
I would much prefer, it's what I asked Michael to do in the House this week, which is use February through the Joint Committee to iron out the creases and then spend...
So we can see on low volume it's drawing like 30 milliamps.
To make sure that from the start of April it is up and running, but just this continual prevarication and delay and extension removes what I think business on both sides of the Irish Sea.
So it's running 100 odd milliamps up on full whack.
The companies want...
Let's just disconnect that. Let's just should I just croc clip that across? Don't like doing it really. Now I'll tell you what I'll do, I'm going to put these directly into the output, just because I don't want stuff, long leads. The other thing is I need to set this for 9 volts now. I don't know if I did that, so let's just double check that a minute. Actually I can do that first, can't I? Yeah, as long as that's off. Just going to connect this up a minute, just bear with me. So I'm just connecting up the radio directly rather than have it on clip leads, that's all. So this is now 9 volts. I need to pop that on. Just change that to, this is where I need the rotary switch or some sort of switch, you see, that I can just switch between the different voltages. 8.9999 volts. 9 volts exactly. There we go. Right.
To reduce death and serious illness from those major strains of COVID that have been subject to research. And in the days leading up to our review point in the week of the 15th of February, we will be accumulating even more data, helped by NHS Test and Trace, so that we can begin to chart a way ahead, starting, if the data allows, with the reopening of schools on March the 8th. And I'll be setting out as much as we can about that roadmap forward.
Medium wave. Just turn that light off a minute. Something else is interfering with that. I don't know what it is. Okay, I think what we'll do next then is to connect the battery back into it and just have a listen to see if that stops with, if we haven't got that noise with the battery. I think we will have. I mean, this is a really noisy environment in here, unfortunately, but that's a whole nother load of pain trying to eliminate all that noise. Let's see if that's still a noise. Yeah, there's still noise in here. No, I think that's usable, to be fair. I think that's perfectly usable. So I've tried all three voltages. The only one that is probably a bit dodgy is 18, as everyone said that it would be. So I think I probably need to. I don't need a massive transformer, do I? You know, to run 200 milliamps, I don't need a huge transformer to do that. I don't think. I've got picture now. Right, let me just catch up then. Yeah, that oscilloscope is a nightmare generation. I've actually unplugged that and pulled the lead out of it to stop it. Phone chargers, yeah, I have got no, I haven't got it. I've disconnected that, so I haven't got any phone chargers plugged in, but I've got the transformer for the LED light plugged in, and I've got the transformers for the other lights here plugged in as well. Just out of shot, but so I've got lots of stuff in here that's noisy. But there was definitely some noise coming through, but only when I held it really close. So I think I don't think that's as noisy as I thought it was. Now, the radio it was really noticeable on. Let me go and get that one a minute, because This is what originally made me think there was a major issue. Let's go and get it a minute. Let's go and get it. Now I think there's issues with this radio anyway. It's not very well, but this is the woodworm radio. Can you remember this one? Where I taped up all the woodworm flight holes to make sure there was no fresh holes appearing in it anywhere. Well, there isn't. So they've all flown. There's not any woodworm left in this. But this is the one that caused me the concern originally. So this is 18 volts. So I can still use my adapter here. Just got to be careful that I put it in the right way. So that one needs to go into negative on that one, and that one needs to go to the positive on that one. And we don't want to be shorting these out. Make sure that's turned off. So it's quite a good idea to build up one of those little adapters for your power supply, and it saves you having loads of leads flying about everywhere. This is obviously only if they're in series. If they're in parallel, you'll need two separate supplies. So let's set this one back to 18 volts. So I think the next thing to do is sort out a circuit to limit the current. That's definitely the next thing to do, so as it doesn't wallop a whole load of current into it, because it's capable of 1.5 amps, and it's not going to like 1.5 amps up it in any radio. So let's just bump this back up to 18 volts. If I can get the probes on it. All right, what's going on there then? Why have we not got 18 volts there then? Oh, yes, we have 7. Gone the wrong way. Let's wind it up to 18. Okay, so let's turn this one on. See, this is the one that's really noisy for some reason. No, I think that is the bridge on that. So over here it's actually okay now, but it was fairly noisy. So it's on long wave, medium wave. So this is the radio that made me think there was a lot of noise, but it seems to be that this, I think there's issues with the amplifier. The amplifier needs a line-in on this, I think. I'm not 100% sure where I am with the amplifier on this one, but this really shows it up. So Nick, hi Nick, is saying the speaker sounds a bit rattly. It is on the R900. Horrible thing. Try not to use perf board in a circuit with mains voltage. A simple HPCB and a cutout groove between primary to avoid. Yeah, you're dead right. Let me just catch up with all the chat a minute. Bear with me. God, dear, oh dear, there's so much chat. I'm way behind again. So I'll show you what I've done, John. I know you're not really supposed to use strip board with mains, but I've chiseled loads of it off, mate. So don't worry about that. Boris, yeah, something with that radio. So LED bulb. Just nip into the shop. Don't blow anything up while you're gone. I'm back, Sean. I'm back again. 2 kVA. Yeah, that's George. The perf board could capacitively couple some line noise. Yeah, you certainly could do. Yeah, I shorted the 2 leads across, Simon, only momentarily, but it was okay for a second and then it just died. So I've probably got to replace a transistor in that one. George, that's more sensible, George. George is saying that he thinks it's 50 hertz induced into the ferrite from the transformer. I think you're dead right there, George. Nick says it's 100 hertz. Afternoon, Rich Yardley. It's full wave rectified 100 hertz. I think you were dead right, Nick. And what it needs is it needs some capacitors across the diodes in the rectifier. Well, it does it or doesn't it? It probably, I'm being over fussy with it, I think, because I wanted to get it as perfect as possible. I'll show you on the back of this what I've done then. Let's just undo my my leads. I'm on the wrong one. Let's just go back to that. I pinched the other camera to look at the scope and the power supply. Okay. So let's get the overhead camera over here. And I'll show you what I've done to the underside of the variable. So this is all disconnected now. Okay, so this is the strip board. Strip board, Vera board. Let's turn that light there off because it doesn't like that light for some reason. That's better. So this is the secondary here. Let's use something plastic because the capacitor still have a bit of charge in it. This is the secondary here. It's the inner two. The outer two are just for fixing. I thought this was a dual output, but it's not. So I've used my drill bit. I think I've put it back now to chisel out quite a bit. But if we look at the main side, which I've got underneath this, let's pop that off. You'll see I've chiseled out quite a large area. Around the mains, so as not to get any flashing across onto the tracks. So I think that's fine. But what I might need to do is just, I mean, you can see where can I put with this here? So I haven't isolated from back that way on the secondary or here, So I mean, I can do that a minute while I think of it. We're getting close to calling it a day so far. Where's my drill bit then? 4mm drill bit out here somewhere. I did have. Have I knocked it on the floor? I don't know what I've done with my 4mm drill bit. So, actually, no, it might be 3.5mm. Yes, 3.5mm maybe. So yeah, probably I could do with just maybe isolating this and this one. So basically any tracks I don't need, isolating them off. I've isolated this one. I mean, these aren't connected to anything, to be fair, but I will. That one's not isolated either. It's the inner ones, isn't it, that are the... This makes your fingers hurt after a while. Okay, so that's isolated. This center track isn't used at all, but it is obviously, it's fairly close here. So I could probably do with pulling the copper out of this area to stop it coupling across, because it is a capacitor if you think about it. Because we've got the conductor, we've got isolation in between, and then we've got another inductor. Another conductor. So really, we've got lots and lots of capacitors all the way along this. Unless you break them, then yeah. I need the RS components supplied at Veriboard spot cutter. I have one somewhere, George, but I do not know where the hell it is. Certainly would save my fingers if I could find the thing. So yeah, there's lots of areas that are in between that don't need to be there. Could cause a bit of stray capacitance. I was always sort of taught that capacitance is very important in RF circuits, but I didn't think it was as important in sort of power supplies. But so yeah, that's all I was doing, just going and removing any unwanted copper. So I did a lot of that yesterday, but I didn't do it all, to be fair. So that could be causing a bit of noise. So this is a prototyping board. This is not the finished product. This is not the finished product by any means. It's purely for me to have a bit more substantial surface to play with for experimenting, really. Does the VP408 fit inside the radio? Let's go camping with the portable radios. So what's the verdict on my power supply then? What do you think? A load of rubbish, or is it worth pursuing further? I mean, the bridge rectifier is in here somewhere. I think it's that row there. So it's easy enough to drop some capacitors across that. I've just got to be careful I don't go across the AC. I need to go from there to there. Yeah, I can wangle 4 caps across that. I'm probably going to cut that noise down quite a lot. But what I wanted to just quickly do, probably can squeeze it for another 20 minutes, is I wanted to have a look at this. The infamous Hacker VP408. Because, as I said before, this will do all the voltages that we need from 6 right the way up to 18. So really what I was trying to do there was replicate this, but with a modern regulator rather than the way that they've done it in here. So that, I think, was what I was trying to achieve. I don't think I have quite, but not far off, I don't think. So let's just take the screws out of this a minute. So the camera's a little bit close here, but I'm just going to have a look inside. So if you look at the fuse ratings, there's 2 fuses in it. There's one on the primary, 250 milliamps delayed, and then on the secondary there's a fast blow 800 milliamp. So this uses an 800 milliamp fuse, which is interesting. So these are horrible to get apart because they got fiddly little leads in them, and fuses hanging off and lights and all sorts. Right, there we go. So that is not a very substantial transformer, really, at all, is it? I'm going to regret pulling this out because it's a pig to squeeze it all back in with this weird and wonderful wiring. So let me go on to the main camera a minute. Let's it's in a bit close. It's getting a bit closer this way. What I wanted to quickly do was get some measurements off of this. I could stick it on my load as well, I suppose, couldn't I? I don't know if I've got any 800 milliamp fuses though. So let's hook this up so as I can do it safely. Where's my little mats? Okay. So what we want to see is the I want to see that what this transformer actually is. There's not a lot of lead on this. I'm going to have to pull it around this way. What we could do with putting another Okay, so if anyone wants to see the schematic of this, I have got that up. I have got that up here somewhere. There we go. So this is the schematic of the VP408. So don't forget this goes up to 18 volts, but look at this up here. 23 to 24 volt offload. That's on the DC off the bridge rectifier, which is very, very similar to what I had on my on my 15 volt transformer, which is what pushed me towards the 15 volt transformer, because obviously this is not a 24 volt transformer, because that would be up in the 30s, wouldn't it? That was what my thoughts were. Let me just get the chat up here as well. So Simon suggested a 50 volt rectifier. This is an 800 volt rectifier, Chris. So probably dropping it back to 50 volt would be good. So any comments on that? I'm gonna fire this up now, and we're going to monitor the AC first of all, if I can hook onto it. Ideally I want to hook onto it, I don't want to be waving leads around in there. So this has got a packaged rectifier in it, exactly the same as mine. Let's see if I can hook it across this way. I'm going to leave that up on the screen for a second while I'm just setting up here. Let's make sure I can get in on the leads. That's that one. Ah, yep. Ah, I'll tell you what, these clip leads are rubbish. Nah, it's gone again. Bear with me, I'm just clipping on. You can't see what you're doing. I know you can't, Dom. I've got the I'm not doing anything. I'm just clipping my multimeter lead at the moment to the power supply. I've hopefully got the schematic up for people to have a look at in a minute, Dom. That was the whole point. Right, so I'm just clipped across the secondary here at the moment to try and find out what this transformer is. So let's go back to the main camera. Zoom out a little bit. Let's get that out of the way. Try and breathe, or my leads will all pop off again. Okay, so I'm across the primary of, the secondary of the transformer. So I'm just going to wind it up on the variac. There's no load on it. So 100 volts, we're on 8. Ah, okay, well, it's 18 volts. Wow, wow. It is an 18-volt transformer. That's interesting. Yeah, the mains fuse is a bit precarious there, Chris, but it's not going to touch anything at the moment. Yeah, I'm at a different angle to you, Chris. It looks a lot closer to that transformer than it actually is. Right, well that's thrown my theory right out the window, isn't it? Because I thought that was I really thought that was a 15-volt transformer, but it's 18 volts. So there we are. That's answered my question. So I need a little tiny 18-volt transformer because I don't know what that thing is doing. Again, I'm quite a way away from that, but it looks like I'm virtually touching that, but I'm miles away from it. Yeah, it's so really, if I look at an 18-volt transformer with a fairly small footprint, the only question I would have possibly is transformer choice to make my little supply here, which works fine. Let's just turn that off. Don't want that floating around on the bench while I'm talking, really. So that's all unplugged now. Yeah, so that is pushing it for 18 volts, but it obviously does all the other. So if I change that for a fairly small footprint 18-volt transformer, how do I work out what volt amps I need? That's something I've not been sure of. Somebody did sort of, I think it was Andrew Alsver, said something in the messenger group, but I think he was sort of saying about half of it, didn't he? I think it's something like we'll do 8 amps if it's 16-volt amps. I'm not sure. So really, I want to try and select next. I've got loads of transformers here now. They'll all come in useful for bits and pieces that I'm building, I'm sure. I've got that whopping great transformer there in the Commodore 64, but that's going to pull amps. That's not milliamps. Flapping fuses help with dissipation, do they? What happened to my drink anyway? Oh, there. I mean, knocked it over. Yeah, PVA, all that sort of business. Volts times amps. DAC 90As. Yeah. You think it gets hot at 9 volts, 200 milliamps? Yeah, probably does get pretty hot, but it's only in a plastic box, Chris. I mean, I've never really noticed them hot, but then I don't really use them much at 9 volts. Usually these are 18 volts. Unless, no, 18 or 12, because they do fit the older version of the Super Sovereign. So 18 volts plus the maximum current draw. So if we designed it for, say, 500 milliamps, Nick, as a maximum, because one of those radios was drawing 300 milliamps, wasn't it? So does that need to be 9 volt amps then? Volt amps equals AC power? What are you on about, Theo? You're being silly now. And don't confuse people. I'm confused enough. Or volt amps? I don't know, I'm confused. So 9 volt amps, yeah, so 18 times 0.5 is 9. So I need to be looking at a 9 volt amp then, possibly. I don't need to build it for an amp, really. So let's have a quick look at some transformers, because I do need to, I need to make this current limiting circuit. So I'm going to need to order some bits for that. So let's look at PCB transformers. I'm going back to my screen now, hopefully. Yeah. Resolving host. So I'm going to go with these PCB mount ones because I quite like those. So I'm going to go with block. So they're nicely enclosed, they're encapsulated. Secondary voltage rating, we want 18 volts AC. Power rating 10 VA, there we go. Doesn't matter whether it's 1 or 2 outputs. That's even better, look. £5, 33 pence. Single output. They're 2 output, 2 output, 2 output. So really that one there, 19 in stock, £6.40 including VAT. 10 volt amps and a 0.5 amps time delay on the input by the looks of it. Oh no, doesn't say actually, does it? Yeah, so it's the same as this really with the 2 pins. One is just for fixing the inner ones of the primary. Sorry, the secondary. This is the primary on this side. So that's that looks good, like it's going to be quite small. .43 by 20, sorry, 43 by 51. So I don't think we need to build it any bigger. So this one's 55 by 50. So that one's actually smaller than the 15 volt transformer I've got. So there you are. So maybe look at getting the 18 volt transformer, then I've got hopefully a power supply that will cover everything, the same as the £100 VP408. And if you're looking at £6 for the transformer, it's a handful of parts. I mean, the heat sink was about, what was that, a couple of quid for the heat sink, 6, 7, 8, at, I mean, you're looking probably 15 quid. 15 quid to build one of those, plus whatever the PCB is, or Veriboard, or whatever you're going to use. So, in theory, you could build a really good one, including the transformer, for 15 quid. And by the time you've shipped it from China for 10 quid, that's taken you 2 months to get it, and you've still got to find a transformer to put on it, I think that's pretty good. Pretty good. Chris is saying about the PSU have a bent metal chassis as the heat sink in. Yes, it's fairly substantial, Chris. If I get you on the overhead camera quickly, because I do need to shoot off now. Mrs. Cruncher will be after me else. Oh, she won't actually. She's good as gold. So if you look at the big transistor there, power transistor, it's a 2N3223. It's mounted on this. That's not right. It's mounted to this metal plate, Chris. So I mean, it's not great heat sinking, is it really? I wonder if how that compares to this. You probably this has probably got equal, if not better, surface area than that bit of metal has got. So, yeah. But interesting to see inside one of these. I don't know if anybody's ever taken these apart. There's not many people got the things where they have got them. They certainly wouldn't want to take them apart. I remember repairing Sean's. That was a pain in the backside, Sean's, to sort out. Turned out that somebody wired the lead up backwards in the end. So there you go, Chris. Just catching on. Copper's expensive. John, I know what you're saying. Benji's saying should be good for 0.5 amps. I mean, we don't need any more than that, but we need something to limit the current, really. The encapsulated PCB transformers are bigger than the open frame version. I know they're probably dearer as well, Chris. I will investigate further before I buy one, but I'm sure I could get one a bit cheaper. Ninja saying that will be good to approximately 500 milliamps at 18 volts RMS. Regulation will be rubbish though. Oh, why is that? Why will regulation be rubbish? Or are you saying the existing, the one that we're looking at, the hacker one, not the one we're looking to build? Transformers haven't improved, so just look for one similar size. Clap for Tom. Yeah, certainly. Shame that unfortunately Captain Tom has passed away yesterday. Real shame. What a guy he was. 39 million, I think he raised for the NHS. Absolutely phenomenal, and a very sad loss. Rich is saying have a look at ICL 200CV from RS, has adjustable current regulator built in, and look online. Just for that, Rich, I'll paste that in a minute. I'll tell you what. Oh, it's in basket, right? L200CV STM electronics, linear voltage regulator, 2 amps, 1 channel, adjustable 5-pin pentawatt. Hell, there's a lot of legs on that, Rich. A lot of legs. Rich has just pointed me to this. STM electronics, 2.85 to 36 linear regulator, 2 amp. So they provide current limiting, thermal shutdown, and input over voltage protection. I assume that you've got to add something in to set the current limit in, haven't you? You must have got to. You must. Where are we? Current limit is on pins 2 and 5. Oh, programmable. Programmable. Do I need to connect that up to some sort of programmer then, do I? Or is it programmed by the components? Yeah. That might be a step too far for me, Rich. That might be a step too far for me, that one, but certainly something I wouldn't mind having to play with. It's just the amps times the transformer output voltage. So if I want 1 amp at 18 volts, it's 18 volt amps. Shush about your 4P4. That's okay, sure. I've got some of those, Chris. The electronics fuse that you recommended, Chris, I have bought some of those, so that really acts as a current limiter as well, does it? You think I should have it on a PCB next time? Oh, what, this power supply or that regulator that Rich just pointed out? Smaller transformers generally have worse regulation than larger ones at 50 Hz. Cores tend to saturate and whatnot. You need the big cores. Yeah, Mrs. Cruncher did do the haircut. Not a bad job this time. Not a bad job. Home barbering at its best. So there you go, people. Hope you've enjoyed that today. It's been a bit of fun. It's a massive learning curve for me, as I've said to some of the guys in the Messenger group. It's been a huge learning curve for me, and I'm still learning all the time. I mean, I've learned more today, even talking to you guys on here. So really appreciate that. So we have got a contribution in today. So let's quickly say thank you to, oh, hang on, Screen Cap Cube. I think we're there. To Fat Tony. Cheers, mate. You're welcome. So I think the idea now, moving further on, is to, I'm going to pop some capacitors across the bridge on it. I'm going to drop the bridge down to a 50 volt bridge as Simon's recommendation, instead of my 800 volt bridge, which is what I had, because originally when I built this, it was just from stuff out of the box, wasn't it? So that's the idea. Hi Harvey, we're just going, mate. Cheers, everyone. So there's more mileage in that project yet. There's still things for me to do, and ultimately, if I can get a PCB, a working PCB that fits a specific transformer, then maybe we can upload that to PCBWay or someone like that, and you guys can buy them for yourself and do whatever you want. If you want to build your own, that's fine. I won't be supplying these built, so don't worry about that. I think that's Andrew Alsfield was concerned that I was going to be building them and selling them. Definitely not. So cheers, people. Thanks for that. See you on Sunday. Not sure what we're doing Sunday yet, but we'll be doing something for sure. So take care, stay safe, and stay at home. If only the neighbours would do that, we'd be fine. But there you go. Cheers all. Catch you all soon. Bye for now.